In this video, we're going to solve a problem related to the application of the second law of thermodynamics. Here is our problem. A refrigeration system must cool mangoes at a rate of 175 kilograms per hour from 34 to 19 degrees Celsius. The refrigerator receives 1200 watts power input. The mango has the specific heat of 2.75 kilojoules per kilogram degrees Celsius, above the freezing point. Find the A. Cooling rate in kilojoules per minute, as well as B. the COP or the coefficient of performance of the refrigerator. Listing all the given, we have power input equals 1200 watts, which is also equal to 1.2 kilowatts. Temperature at state 1 is equal to 34 degrees Celsius. Temperature at state 2 is equal to 90 degrees Celsius. We have a rate of 175 kilograms per hour and a specific heat of 2.75 kilojoules per kilogram degrees Celsius. So what are we going to calculate in this problem is the A, the Q dot sub L or the rate of cooling in kilojoules per minute, and B, the COP sub R or the coefficient of performance of the refrigerator. Solve for the cooling rate in kilojoules per minute. Note that the rate of cooling is given by the equation Q dot sub L equals m dot times C sub P times the quantity of T sub 1 minus T sub 2, where Q dot sub L is the rate of cooling, m dot is the mass with respect to time or the mass rate, C sub P is the constant pressure specific heat, and T sub 1 and T sub 2 are the temperature at state 1 and at state 2 respectively. So we all have the given for the mass rate, the specific heat, temperature at state 1, and temperature at state 2. So plugging in all the values, we will get Q dot sub L equals 175 kg per hour times the specific heat, which is 2.75 kilojoules per kilogram degrees Celsius, times the quantity of temperature at state 1, which is 34 degrees Celsius, minus the temperature at state 2, which is 19 degrees Celsius. Calculating, we will get Q dot sub L equals 7,218.75 kilojoules per hour. And since we are looking for the rate of cooling in kilojoules per minute, we need to convert hour into minute. And we will get Q dot sub L equals 7,218.75 kilojoules per hour times 1 hour over 60 minutes. So eliminating the unit hour, we'll get Q dot sub L equals 120.3125 kilojoules per minute, and this will be our rate of cooling, and we can use this to solve for the COP of the refrigerator. Next is solve for the COP or the coefficient of performance. So coefficient of performance of refrigerator is given by the equation COP sub R equals Q dot sub L over W sub N, where COP sub R is the refrigeration coefficient of performance, Q dot sub L is the rate of cooling, W sub N is the work input. So note that our work input is the power input, which is 1200 watts and is also equal to 1.2 kilowatts. And from our previous answer, we know that our rate of cooling is in kilojoules per minute. Kilojoules per minute. So we need to convert this into kilowatts since our work input is in unit watts. So convert 120.3125 kilojoules per minute to kilowatts. We have 120.3125 kilojoules per minute. That's 1 minute over 60 seconds. So eliminating this in unit, we will get 2.0052 kilojoules per seconds or kilowatts, and this will be our rate of cooling. Now we can solve for the COPR or the coefficient of performance. So coefficient of performance is equal to the rate of cooling, which is 2.0052 kilowatts, over the work input, which is 1.2 kilowatts. Eliminating this in unit, we will have COP sub R is equal to 1.67, and this will be our coefficient of performance of the refrigerator.